Let's take a look at compound inequalities. We've got two problems up here. Both of them look exactly the same except for the connector between them. The first one has an and the second one has an or. And so I'd like to talk about the difference between those two. Let's start out with the first problem. And what I'm going to do is just graph each of these inequalities separately. We'll start out with the x is greater than or equal to 2. Right? And I'll do that one in green. And greater than or equal to, the equal to part means we close in the circle at 2, right? The greater than means numbers larger than 2. And in fact, I can do that on both of these. So since we're dealing with the same problem. Okay, so all I'm doing is I'm just graphing x is greater than or equal to 2 in both of these cases. Now for the second one, I'll do that one in more of an orange color. X is less than 5, open circle, and less than means go to the left. And we'll do that in each of these problems. Alright, so we're starting out with what looks like the same problem, but now the interpretation of the and the or makes a huge difference. Let's start with and. What do we mean by and? It means that in order for the inequality to be satisfied, both of these inequalities here have to be satisfied. Well, looking at the picture, you see that numbers that are left of 2 aren't satisfied, right? Only one of those inequalities works, not both of them. The x is greater than or equal to 2 only goes to the right of 2. The same can be said for over here. Only numbers bigger than 2 but not less than 5 work. And so what it boils down to is it's only those numbers between 2 and 5 that are satisfied by both of these inequalities. And so we can just graph or shade that portion of the graph, and that's the end of the story. You could express this algebraically. You put an x between them, the 2 and the 5, and 2 is less than or equal to x, but at the same time x is less than 5. So we could write this expression algebraically like that. All right, let's take a look at the second one. A little bit trickier, I think, because of the connector or. What do we mean by or? Or means either one of these conditions has to be satisfied. Either that one, or both. Alright, so any part of the graph that's covered by at least one of the lines is part of the solution set. That's what or means. Any part of the graph that's covered by at least one of those lines. Well, clearly, numbers over here work, numbers over here work, and numbers between 2 and 5 double work, but it doesn't matter, they're still part of the solution set. What we see here is that the entire number line is covered. And if the entire number line is covered, it means that all real numbers, and that's the fancy symbol that we use for real numbers, all reals are a solution for this inequality. So that's how you might express it, or you could just write all reals. But it's just interesting that that slight difference between the and the or makes a difference in what our solution set is. This is a limited solution set. This is the entire set of real numbers. Take a look at this problem and apply it to any other problem. Just remember, draw the two graphs separately and just analyze which parts of the lines are overlapping the number line, and you should be able to get every one of these compounds correct.